Hello everyone, welcome to section 6.2 in geometry. We're going to talk about all the different or a bunch of different characteristics of parallelograms. What's special about them, and then how can we solve problems knowing that. The first characteristic I want to let you know about should make sense to you. Since it's a parallelogram, opposite sides are parallel and then the other sides would be transversals. So consecutive angles would be the same as same side interior angles within parallel lines. Therefore, consecutive angles in a parallelogram will always be supplementary. They'll always add up to 180. Another characteristic of parallelograms is that opposite angles are congruent, always. So this angle and this angle have the exact same measure. And these two are congruent to each other. So these two are supplementary, these two are congruent. That's always true if it's a parallelogram. A characteristic that's related to that is if one angle in a parallelogram is a right angle, is 90 degrees, then all of them are 90 degrees and it's a rectangle. That would have to be the case because opposite angles are congruent and consecutive angles are supplementary. So just having one of them be right angle turns it into a rectangle. So I wrote one right angle makes a rectangle. Another characteristic of parallelograms is that opposite sides are always congruent. So in this parallelogram, these two sides would be exactly the same, and these two sides would be congruent to each other. So not only are the opposite sides, the two pairs of opposite sides parallel, they are also congruent. What I'm telling you in this video may seem common sense, and of course you don't know it, so you don't need to write it down. I would highly recommend that you keep this in a notebook, and the reason is because we're going to go through several different one of these polygons, especially quadrilaterals, and it gets confusing, some of these different characteristics, and to keep them straight, a notebook would be helpful. Okay, the last characteristic for parallelograms that I want to share right now is diagonals. So a diagonal connects two non-consecutive angles in this parallelogram. And if I draw both diagonals, they bisect each other. My diagonals aren't perfectly straight, but it's good enough to give you an idea. They exactly cut each other in half, which means this segment here, it would be congruent to this one, and this segment would be congruent to that one because the diagonals bisect each other. That is true of all parallelograms. Here's an example of the kind of problems that you could get in a homework or a quiz or a test. There's a parallelogram on the board with the two diagonals drawn, and there are several labels on it. This is parallelogram ABCD. And from this information, can you find the length of DC? So DC is this side right here. Because it's a parallelogram, it should be congruent with AB, and AB is labeled 6.3, so DC is also 6.3 meters. This is knowing these characteristics helps you to solve these kind of problems. I need to find EC, and I know that AE is 4.2, and I know that the diagonals bisect each other. So EC has to be the same as AE, so it's also 4.2 meters. The fact that it's bisected means it's cut exactly in half, so both halves are equal to each other. All right, I need to find ED next. ED is this length right here. I don't know what that is, but I did write up here that BD is 11.6. So this entire diagonal is 11.6. It was bisected by this diagonal, so ED should be half of 11.6, which happens to be 5.8. So we know ED is 5.8 meters. So those are our problems involving side lengths. Let's look at some problems involving angles. I need to find the measure of angle ADC, which is this angle right here. I know that angle ADC is congruent with angle ABC, and it's been given to me that angle ABC is 72 degrees. Therefore, angle ADC also has to be 72 degrees because in a parallelogram, opposite angles are congruent. Okay, the next angle I'm asked to find is angle DAB. DAB, that's this one here. And I don't have any information about that except I do know this angle. I just said that ADC is 72 and these two are supplementary. So I take 180, I subtract 72, and that's what this angle needs to be. And my last one is angle DAC, which is this angle right here. There are several ways that we could find this. One way I'm going to point out to you is, remember, these are lines are parallel. And so this angle and BAC would be alternate interior angles. That makes this 63 degrees, doesn't it? Just wanted to point that out to you. You can see that inside of parallelograms. So if you want to find that, know that DAB is 108. So if you go 108 and subtract that 63, it'll give you the other half, which is DAC. So that should be 45 degrees. What's wonderful about math and about geometry especially is that there are many different ways that you can use to approach a problem. This angle, you could have looked at ACD as a triangle and made those three angles add up to 180. You would have gotten the same answer, whichever approach that you take. Here's another problem involving parallelograms. The directions for this problem are to solve for every angle and every side in this parallelogram. So understanding the relationships between the angles and the sides are really important. Let's start with the angles. I think that might be a little simpler. I have this angle here, angle J is 7A and angle M is 13A. Those two angles are consecutive. If they're consecutive angles in a parallelogram, then they should add up to 180. So 7A plus 13A equals 180. So when I combine like terms, that means 20 times A equals 180, and when I divide by 20, then that means A is equal to 9. A equals 9. Now I can plug that in. If A is equal to 9, this angle, angle J, is 7 times 9, or 63 degrees. And angle M is 13 times 9, or 117 degrees. Now that makes finding angle L and angle K easy because opposite angles are congruent. So if J is 63, then L is also 63 degrees. And if M is a 117, then K is also 117 degrees. And we found all of our angles. Now let's find our sides. And this one is a little trickier. We know because it's a parallelogram that opposite sides are congruent. That means 2x is equal to 5y minus 2, and x is equal to 2y plus 1. So I will write those relationships down. Now this looks like I can't solve this because I have two variables, but I have two equations, and x and y works in both. So I can put, or you have to remember, how do I solve when I have two equations? So I need to put them together. Because this one is solved for x, I will use substitution. Do you guys remember this from algebra? I will make my x is equal to 2y plus 1. So in place of x in the other equation, I will put 2y plus 1. I will substitute it, and then I'll be able to solve for y. So where the x was, I put 2y plus 1. I'm going to distribute because this was 2 times x, so I have to multiply all of 2y plus 1 times 2, put my y's together and my numbers together and solve for y. Okay, I did that and I got that y is equal to 4. So I'm going to plug in 4 for y in one of these sides that just has a y in it. And 2 times 4 plus 1 would be 9. So ML, or LM, is equal to 9, which means JK, because congruent sides are opposite each other, or X, is also equal to 9. And if Y is 4, 5 times 4 is 20, minus 2 is 18, so KL is 18. And that means MJ also has to be 18. And sure enough, 2 times 9 would be 18. It should be consistent and work on all 4 sides. And so we have solved for all 4 angles and all 4 sides. Here's another theorem that's related to parallelograms. It's not about parallelograms, but the similar characteristics are shared, so we're going to explain this at the same time. If I have 3 or more parallel lines, and we're just going to pretend these are parallel, and they're cut by a transversal, and that transversal is divided into congruent segments. So this segment and this segment are congruent. If that's the case, then any transversal across those parallel lines would also be divided into congruent segments. Basically, we're saying our parallel lines are evenly spaced apart. So if I drew another transversal like this, then these 2 segments would also be congruent. Since those are, so are those. That's the congruent division of transversal theorem, but basically that's what it means. And that's why it works, because the fact that these are congruent means my parallel lines are evenly spaced. Okay, we'll practice a few of these parallelogram problems just so you get the hang of it. And I want you to pause the video and try just to make sure check your own understanding. So I have a parallelogram here. I have labeled the sides. And from my labels, can I figure out the lengths of A, B, and C, D? I paired them together because they are opposite sides, which means they'll have the same length. And also BC and AD also paired together for the same reason. It's a parallelogram, which means opposite sides are congruent. They have the same length. So to find out about AB and CD, I need to realize 3x minus 1 is equal to 2x plus 3. So find your answer for that and see what you get. Hopefully you discovered that x equals 4, and when you plugged in 4 for x in both of these, they both came out to be 11. So that's the answer for those 2. Now go ahead and find the answer for BC and AD. Okay, hopefully you set up that 3y minus 7 equals 2y plus 1 and solved for y. You got y equals 8. And when we plug that in, then that means these 2 would be 17. 16 plus 1 and 24 minus 7 would be 17. That's how you solve these parallelogram problems. Okay, let's do a similar type of exercise, this time finding the measures of angles. I've been given 2 expressions for angle A and angle C. Can you find their measures? Remember, this is a parallelogram, which means opposite angles are congruent. So that's how you set up your equation. 4x minus 9 equals x over 4 plus 51. Pause the video, figure it out, come back and see how you did. Okay, this one was a little bit tricky because we had x over 4, so I'll walk through how I solved it and see if that helps. I set it up here and I added 9, so 51 plus 9 is 60. And I didn't want to subtract 1/4. I just didn't want to do it. So I multiplied everything by 4. This became 16x, this became 1x, and this became 240. And then I solved for x and I got x equals 16. That's much easier to deal with. Now when I plugged in that, 16 divided by 4 is 4, plus 51, I got that these are 55 degrees. And that's the correct answer. Now it looks like you can't solve for the other two because there's no expressions there, but remember it's a parallelogram, which means consecutive angles are supplementary. So if I just take 180 and I subtract the 55 degrees, I have the other pair of angles, which would have to be 125. That's one way, that's a method for solving these parallelogram problems. Okay, before we end this video, I do want to go over how to do a construction. I have a segment here, AB, and I want to construct 3 segments that are each a third of AB, which basically really means I just want to divide this segment into 3 congruent segments. How do I do that? How would I divide it evenly? I know I could bisect it, perpendicularly bisect it, we've done that. But to divide it into thirds would be a lot trickier. So I'm going to show you how you can do that, and it's based on what we learned earlier about those parallel lines being cut by a transversal. It's based on that. So step 1, I've got my segment AB. I am going to make an acute angle off of A. I'm going to draw a ray from A, making an acute angle and making it kind of a little bit longer. So here's my straight edge. I've got the end at A, and I'm just going to draw a ray there and create an acute angle. The exact measure, of course, is not important, just as long as it is acute. So I've got that. Next, I'm going to take my compass. Okay, I have taken my compass. I've opened it to a particular opening, not a very big one, a rather small one, because remember I'm thinking 1/3 of this. And now I'm going to do is I'm going to mark off 3 congruent lengths along this ray that I just constructed off of angle A. Not on the original AB, but off of this ray. So I'll put my point at A, mark the first one, then shift the second one. So let me show you what I mean. Here's my first mark. Lift it, do my second mark with the same compass setting, and my third mark with the same compass setting. Now all those 3 marks on that ray are evenly spaced. Now what I want to do is I want to construct parallel lines, knowing these are evenly spaced, parallel lines through AB, but they need to be parallel. So the first thing I'm going to do is I'm going to take this 3rd mark and I'm going to connect it to B. So I drew that line. Now I want to draw lines parallel to that. In order to do that, I need to construct some corresponding angles. So I'm going to get my compass again, and I'm going to create some arcs off of each one of those tick marks that I did here. Okay, so I took my compass and I drew my 3 arcs. Now I'm going to measure this distance and match that. So with my compass, how far apart are these 2 points? I'm going to open my compass to that setting. It looks like it's right there. So now I'm going to repeat that in each one of these arcs. Mark that and mark that. And now I should be able, this is already connected. Connect that and connect that through AB. Okay, so I connected them, and that means these 3 segments are equal. If you look in the book, at the example in the book, you notice these original arcs were longer. It would have been easier if I had done that. I made mine a little bit small, which with my compass is unwieldy, but that's the process for drawing parallel lines. Do a couple of them till you feel comfortable, and then write the directions so that you could remember when you do it again. And that's it for constructing parallel line segments. Or dividing, I should say, dividing a segment into congruent sections by constructing parallel line segments. That's the way to do it. Okay, now we're going to use the congruent division of transversal theorem to solve a few problems. We're going to pretend, first of all, that these 3 lines are parallel. I marked them that way. Notice I marked AB is congruent to BC. Based on that information, can you find EF if DE is 5 centimeters? Hopefully you remembered, if these are congruent, so will these be. So if DE is 5, EF is also 5 centimeters. Another one, this time we're going to find DE if DF is 12. If D to F is 12, what's DE? Hopefully you realize these are congruent, so it has to be half of 12. The answer would be 6 centimeters. Whoop, not meters, 6 centimeters. Okay, now we want to find DF, the distance from D to F, if EF is 4.5. If this part is 4.5, well, what's the whole thing? Realize 4.5 is half of DF, so I just double it. DF would be 9 centimeters. So those, again, those are examples of the kind of problems that you can get. So there are a few more problems that I could give you to practice, especially in dealing with diagonals bisecting each other, those kind of things. But hopefully between that and the homework, you will have enough to get started and have success with remembering the characteristics of parallelograms. So that's it for this video.